Today we're going to analyze graphs. Let's look at the first one. It says lines that go up from left to right have a positive slope. The function, the value of y, is increasing or decreasing from left to right. If you remember, it is increasing. Lines that go down from left to right have a negative slope. The function, the value of y, is decreasing from left to right. Lines that are horizontal have a zero slope. They are neither increasing nor decreasing. The function, the value of y, remains steady or the same. Take a minute, pause the video, and I want you to match the graph below with the words above that describe it. If your answers are B, then C, then A, you matched it correctly. Next part says write linear or nonlinear in the blanks to describe each interval. Okay, so look at from A to B. Is that linear? No. So we're going to write non-linear. Okay, what about from B to C? Well, B to C is a line, so that would be linear. Here it says write increasing, decreasing, or constant to describe the behavior of the function in each interval. Again, constant would be a slope of 0. So let's look. From A to B, well, that's going up, so that is increasing. I'm going to put IN for increasing. From B to C, it's staying straight across, so I'm going to say it is constant. From C to D, again, we are increasing. And from D to E, notice we are decreasing because we are going down. Okay. The function from A to B is steeper or closer to a vertical than the function from C to D. So again, if we're looking at the function from A to B has a steeper slope than from D to E. Oops, sorry, C to D. Can't read. So A to B is closer to a vertical line than C to D is, they're saying. Which of these intervals has a greater rate of change? Remember, rate of change is the same as a slope. So again, if we're looking for the greater rate of change, the one with the greater slope would be from A to B, because it has a steeper slope. This is because distance is covered in a shorter amount of time. Now look at example 2. Example 2, along the x-axis we have time, and along our y-axis we have distance. Take a second, pause the video, see if you can determine which car has the greater speed, A or B. Okay, looking at it, you want to find the car with the steeper slope. So we're going to go with car B. So if you wrote car B, you are correct. Car B covers the same distance as car A in a shorter time. Notice they both end up here, whatever this distance is. Here, let's say that's 20 miles. So if that up here is 20 miles, they both went 20 miles. And let's say down here is time. Let's say this is 1 hour, but over here this is 2 hours. So that's why car B covers the same distance as car A in a shorter time. That means car B is going faster. Car B has the steeper slope. Example 3 shows Michael walking from his house to school and then back home. So Michael starts out at his house, which is right here. Okay? He is walking, walking, walking. Time is increasing and distance is increasing. Here, he plateaus. That means the straight line here with a zero slope means he stopped for a few minutes to take a break, maybe to talk to some friends. Then he walked faster. He realized he's running late, so he's walking faster. Therefore, the slope is steeper. He now arrives at school. Now, while he's at school, time goes on, but his distance from home does not. So time is moving, but the distance is not. And then finally, school gets out and he walks home. Take a moment, read example number 4 to draw a graph to represent this situation. Chad leaves his house and drives toward school. After a few minutes, he remembered he left his project at home. He goes back home, gets his project, and drives to school with no stops. Pause the video, try to draw what that is, and then when you're done, replay, and I will give you the answer. So here we have Chad at his home. There we're starting here. Here's school up here, his final destination. He leaves his house, he drives towards school. So he's driving. He gets to a certain spot and he's like, uh-oh, I have to turn around and get my project. So there he goes back home. And then he gets his project. He may stay at home, run in the house to get his project. So maybe I'll draw a little straight line there because he runs into the house to get it. And then he drives straight to school. So that's what I would have. This little zero slope down here, you don't have to have that. I just put mine in there. Let's look at example 5. Which situation is represented in the graph? So you have to read each one and try to figure out what's going on. Notice, as time goes on, the temperature goes up, then it goes down, and then it stays the same. So it says Julie's temperature was the same all the time. No. I just said it went up, down, stayed the same. Julie's temperature went up. She took a fever-reducing pill, and it went down to normal. That sounds good. I'm going to circle B for now. I'm going to read the rest, though. Julie's temperature went up and down several times. Nope, it went up once, down once. Julie walked to the top of a hill and then back down to flat ground. No. Okay, so we're definitely sure it's B. Example 6, riding a Ferris wheel. Why does this graph not show a correct representation of a function which shows the distance above ground related to the time someone has been riding the Ferris wheel? Think about that, see if you can fill in the solution, and then I will go over it with you. Okay, so after looking at this graph, it says the distance above the ground. This actually looks like a Ferris wheel. Okay, and the reason why this does not represent a function is because time cannot go backwards. Here it's starting here, it looks like it's going like this, but then time is going backwards. Time cannot go backwards, and time does not stop. It always moves forward. The above graph is not a function because it does not pass, if you remember, our vertical line test. Vertical line test. So if I were to draw a vertical line anywhere in this function, it's only allowed to touch in one place. Here it's touching that function in 2 places, so that is why it is not. Now, I could probably do a better graph just to quickly show you. Here we have time, here we have distance above the ground. You get on the Ferris wheel on the ground, right? The Ferris wheel goes up, then you come back down, then you go back up, then you go back down, then you go back up, then you go back down. Hopefully that makes sense as you're riding the Ferris wheel. And eventually, you get off on the ground. Hopefully, as long as the Ferris wheel doesn't break. Okay. Good luck on the practice, and then you're going to work on the assignments in Google Classroom.